All right, here we are on our check on learning. So let's get started. So it says, how are the zeros of the polynomial function p of x equals all of that related to the coefficients of p of x written in standard form? So first things first, I'm going to write down the zeros. So our zeros are let's see here, 1 over 2, negative 7 over 5, and negative 9 over 8. So again, I just looked at each one of these and set those equal to 0 to find those zeros. So now we need to put it in standard form. So we're going to be doing a little bit of math. So 2x times 5x, 2x times 7, negative 1 times that, and so on and so forth. So let's see here. 2x times 5x, 10x squared, plus 14x minus 5x minus 7 times 8x plus 9. So now we're going to add this next one in. So 8x times 10x, 80x cubed, plus, 8's in double digits. They're killing me here. 8 times 14. That's going to be 112x squared minus 40x squared. I guess I could have combined like terms. That would have been smart, but too late now. Minus 56x. And then we're going to start with our 9 plus 90x squared plus 9 times 14, 126x minus 40x. Love it when I take the long way. That should be a 45, because 9 times 5 is 45, not 40. And then 9 times negative 7, negative 63. So now we're going to combine like terms. We got a squared, we got a squared, we got a squared. We got an x, we got an x, we got an x. And here we go. So we've got our 80x cubed plus, we've got a 112 minus 40 plus 90, 162x squared. So then our x's, got a negative 56 plus 126 minus 40 plus 30x minus 63. So our beginning coefficient is 80. Our what is that? Constant is negative 63. So now we can look through these different answers and figure something out. So here are the zeros, negative 1/2, negative 27, or 1/5. So I'm going to go ahead and mark that out. Those are not our zeros. The zeros, negative 7 over 5, negative 9 over 8, or 1/2. of p of x have denominators that are factors of the leading coefficient, I'll agree to that. So I was looking at our leading coefficient is 80, making sure that all of our bottom numbers or denominators were divisible by 80. And the numbers that are, and let's see here, and numerators that are factors of the constant negative 63. So again, I'll agree to that too. So I'm going to go with that. Just we can go through and make sure. Our next one, I was just skimming it. I don't know where they would get negative 53, so that's wrong. Then the fourth one are zeros. That one's wrong. That one's wrong. That one's right. So that one's wrong. So I like that. Let's go for that. So use rational theorem to determine the rational zeros of the polynomial function of that. So they didn't really make it easy on us. It would have been a lot easier if that was 1, but whatever, we'll figure it out. So our numerators of our factors are going to be, so I'm just going to put numerators, could equal plus or minus 1, plus or minus 2, plus or minus 3, plus or minus 6. Our denominators, plus or minus 1, plus or minus 2, plus or minus 5, plus or minus 10. So it's not terrible. That's the nice part. So all of our zeros are going to be, did I do that right? Alright, so it says use the rational zero theorem to determine the rational zeros of the polynomial function. As a reminder, the theorem says all of your zeros are going to be m over n, where m is the factors, or is a factor of the constant, and n is a factor of the leading coefficient. So this could totally take a while. We'll see how it goes. Our constant is negative 10, so our factors for that are going to be plus or minus 1, plus or minus 2, plus or minus 5, plus or minus 10. So our so that is our numerators. Our denominators could be plus or minus 1, plus or minus 2, plus or minus 3, plus or minus 6. Because again, I got that from our leading coefficient. So I'm going to start with a 1 on the denominator so that we can use some of the techniques that we have already learned. So we're going to set up our chart with our coefficients. I didn't plan this out very well with my white space, but So we've got 6, 19, 9, negative 10. Man, they're hitting you with a doozy off the top here. I'm just going to grab my calculator because I'm not doing those 19s. So let's see here. So we're going to start with our factors up here. So we'll start with 1. Bring the 6 down. 6 times 1 is 6. 19 plus 6. I didn't really need a calculator for that, but 25. 25 times 1 is 25. Plus 9 is 34. 34 times 1 is 34. Minus 10 is 24. So that's not it. So let's do 2. Bring the 6 down. 6 times 2 is 12. 12 plus 19 is 31. Yeah. 31 times 2 is 62. 71. Wow, they showed no mercy with this problem. $134. I don't know. I'm just going to try the -1 too while I'm at it. 6 times -1. 19 minus 6 is 13. 13 times -1 is -13. 9 minus 13. -4. -4 times -1. +4. So that's going to be -6. I don't know if our smaller remainder or closer to 0 remainder is better or not, but we're going to keep trying. It's alright, excuse me. So we brought our 6 down. 6 times -2 is -12. So that's going to be 7. 19 minus 12 is 7. 7 times -2 is -14. So we got -5. -5 times -2 is a +10. Minus 10 is BAM! Thank goodness. So we know that -2 is a 0. So that means we got x plus 2. And then what do we got left? We got a 6x squared plus a 7x minus 5. Let's see here. Am I going to be able to factor that? Trying to think. Not coming up with anything easily. So, we'll stick with our zero theorem thingy. All right, let's go. Let's get it. Let's get it. So we've knocked out a couple already. So, and we can set up a new chart just with that one. So we'll set that one up over here. 6, 7, and 5. So on the bright side, 5 doesn't have a lot of factors in it. So we'll come up over here. So that's our top. Our denominator is plus or minus 1, plus or minus 2, plus or minus 3, plus or minus 6. So we can try our whole numbers first. So we go 1, so 6 comes down, 6. 6 plus 7 is 13. 13 times 1. 18. So that's not it. 2. I don't think it's going to be a positive number. I'm just saying. So let's try negative 1. 6 times negative 1. 6. We got 1. So we got negative 1. So that's 4. Negative 2. We don't need to do negative 2. That's crazy talk. That's not a factor. Negative 5. 6 times negative 5 is negative 30. So that's going to be 23 with the negative type. Oh, geez. 23 times 5. 1, 1, 5. Still not it. I'm still sticking with I think it's negative, so we're going to have to go into our denominator. So we're going to have to do some fractions here. So, or I guess over here, so this fraction. So we'll start with 1/2. So 1 on top, 2 on bottom. 6 comes down, 6 times 1/2 is 3, so that's 10. 10 times 1/2 is 5, and that is 5. Wait, did I do that right? Hang on. 6 comes down, that's 3. 3 plus 7. That should be a negative right there, shouldn't it? Oops. But on the bright side, so when I saw that 5 right there, I was like, wait a minute, that seems weird. Because that was the same number. So I was wondering if I was doing something wrong. Clearly I was. So all of these numbers are technically wrong, but I don't think they were zeros anyway. And hey, we found one, so who cares? So we know that x plus 2 is 1. We know that x plus 1/2 is 1. We could also say that 2x plus minus 1 is a 0. And let's see what we have left. We just have a 6x minus 10. So that we can just solve normally. 6x equals 10. X equals 6 over 10, which equals 3 over 5. Ha! There was another positive one in there. I did that wrong again. Man, must be getting late. So x is 10 over 6, which would equal 5 over 3. So that's going to be x minus 5 over 3. Yeah. So our zeros are, yeah, I got that wrong. That should be a plus. So our zeros are -2, -5 over 3, and 1/2. So as you can see, these problems can get hairy real quick. So let's see what else we got. All right, we're back, and you'll probably notice that there was a cut in between that last problem and this one. Man, I had to walk away. So, anytime you're getting frustrated or you just need a brain break, oops. Anytime you need a brain break or anything like that, I mean, that's how the game's played. So, anyway, we came back and we're ready to go. So, once again, use the rational zero theorem to determine the rational zeros of the polynomial function. This time, our coefficient or our denominator is 1, so that's very helpful. And then our constant is -8. So the only ones we gotta worry about are plus or minus 1, plus or minus 2, plus or minus 4, plus or minus 8, right? All right, too easy. Especially after that last problem, this should be no problem. So let's make our coefficients 1, 6, 7, -6, -8. So yeah, our denominator is 1 because of this guy right there. So we're going to go through and try to find our zeros. So we will start with a positive 1. So bring the 1 down. 1 times 1 is 1. So 6 plus 1 is 7. 7 times 1 is 1. Sorry, 7 times 1 is 7. Plus 7, 14. 14 times 1 is 1. Minus 6 is going to be 8. 8 times 1 is 8. And first try. Doesn't get any better than that. So we know that, let's see, where am I going to write this? I'll write it over here. We know that x minus 1, because remember when we plug in 1, that has to equal 0, is one of our zeros. So what do we have left? We've got x cubed plus 7x squared plus 14x done and plus 8. So we get to do this whole thing all over again, unless for some odd reason we could factor that. No, we can't. I almost thought we could factor it by grouping, but I don't think we can. So again, our leading coefficient is 1. Thank goodness. This guy is 8, and so we can do our same thing all over again. So we've got 1, 7, 14, and 8. So we've already done 1, and we already knew that oh no, that's 1. So let's try, I don't know, do you want to go to the negative side or the positive side? I don't know, let's try -1. So -1, so 1 comes down, -1 plus 7, 6, 6 times -1, -6, so that's going to be 8, -8, oh, so got lucky. So now we know that x minus 1, x plus 1, let's make some more white space here. No, I can't make any more white space. Oh, whatever. And then x squared plus 6x plus 8. So if we look at this guy right here, that's probably going to be factorable. So 2 times 4 is 8. Add those together, you get 6. So we're going to bring this whole thing down here. Bring the whole thing down there. So we have x minus 1, x plus 1, x plus 2, x plus 4. Right? 4 times 2 is 8, goes there, and yeah, totally. So then our zeros are going to be 1, -1, -2, and -4. Those are the numbers that we can plug into there and get 0. So that's what we're going to stick in. 1, -1, -2, -4. And this time I did have the answers written down, so I know that those are right. So Tara had a sale and tracked her profits for 6 consecutive weeks. Her total profits for each week of the sale can be represented by the polynomial function, that big long thing, where W is the whole number of weeks after Tara started the sale. How many weeks after the sale started did Tara have $8,000 in profits? So basically, when does this whole equation equal that, right? So, we're going to set it equal, and then we're going to minus it. And so I'm going to skip a couple of steps. I hope you kept up with what I'm doing. Minus 300 W3 plus 1060 W2 plus 300 W and then 3920 minus 8,000 negative 4080. So that's the thing that we're working on. You know what I'm going to do? I'm going to factor out a 20 out of that whole thing. I think I can do that. Because I don't want to deal with that. I don't want to deal with this thing right here. I really don't. So we're just going to factor a 20 out. See, everything looked like it would be factorable, but Not sure. So 300 divided by 20. 15w cubed plus 1060 divided by 20. 53w squared. 300 divided by 20. I already did that one. Plus 15w minus 204. So we still have this number, that's gonna be a fun one, but at least this guy right here is a 1. So again, we're gonna set up our chart, and away we go. So for now, I can actually ignore that 20, because if this is 0, then timesing it by 20 is not going to do anything. So we're going to set up our chart. So we got 1, negative 15, 53, 15, negative 204. And since we're in the real world, I don't have to worry about negatives because you can't have a negative number of leaks. So we're going to start with 1. Bring the 1 down. Negative 14. 39. 54. And then 204 minus 54. Negative 151. So we go into 2, bring the 1 down, 2, negative 13. So that times 2 is a negative 26. 53 minus 26, 27 times 2. Hang on. Yeah, 27 times 2 is 54. And 54 times 2. Wait a minute. I messed up here. Think. So 1 times 2 is 2. Okay, negative 13 times 2, negative 26, plus 53 is 27. 27 times 2 is 54, plus 15 is 69, times 2 minus 204 equals a negative 66. So 3, and we got 1, negative 12, negative 12 times 3, negative 36, plus 53 is 17. 17 times 3 is 51, plus 15. So we got 66 here, times 3 minus 204, negative 6. I don't know, hopefully that's a good sign. 4 negative 11. Hey, look, there's a pattern. Negative 11 times 4 is 44. Negative 44. 53 minus 44 is 9. 9 times 4, 36 plus 15, 51. 51 times 4 is 204, minus 204 is 0. Bingo. So at this point, we know that 4 is a 0, and that's probably going to be the number that makes the most sense. So we're going to say it took Tara 4 weeks. Alright, last but not least, Jason makes different sized apple cinnamon pastries that are in the shape of a cone. Hey look, they conveniently gave us the volume function of a cone. Pastries where R is in radius and inches in the base of the pastry. Use successive approximations to determine the radius of the pastry to 3 decimal places, where the volume is 32 inches cubed. Start with the interval 2 to 3. That's cute. They gave us the interval. So we need to find R. V of R is equal to, actually I don't want to write that down. Our whole function, 0 equals 7/3. I don't know why I did it that way. Pi R squared minus 32. So remember, I set the volume equal to this number. I subtracted it from both sides, and here we are. So at this point, I'm going to do this on my calculator, just because that's how I assume most of you would end up doing it as well. So I'm going to the top left corner, the y equals button, and then I'm going to type this equation in. So 7 divided by 3, I put that in parentheses just in case. Do I have a pi button? I do. Pi. So I'm just going to use x for my r squared minus 32. So now instead of going to the graph, I'm going to go to the table. So if you push second graph, that will get you to the table. So now every time you enter a value into the x coordinate, it's going to poop out a y coordinate for you. So we're talking from 2 to 3, so I can enter 2, hang on, I gotta change my, I had to change my settings real quick. So if I type in 2, it gives me negative 2.6. If I type in 3, it gives me a positive number. So now I'm going to type in 2.1. I get 0.32. So 2.2. 3.4. 2.3. That's weird. I assumed. So it's just getting bigger. So 2 is negative, 2.1 is positive. So it must be in between there, right? So I'm going to start writing this stuff down. So I'm at 2.0. Okay, so 2.01 is a negative 2.3. 2.02, the negative number. 2.03, 2.04, all still negative. 2.05, 2.06, 2.07, we're getting close. 2.08, 2.09. Okay, so 2.09, we finally get into a positive number. So that means 2.08 is my next digit. How far are we going? To 3 decimal places. Okay, so I got to do one more. 2.081. 2.081 is a negative number. 2.082 is a negative number. 2.083, but we're getting closer. 2.084. 2.085. 2.086. 2.087. 2.088. Oh my gosh, 2.089. That's weird. It never went positive. It was negative the whole time. So 2.089. 1. 2.0892. Wow, 2.089 is all I need, isn't it? Yeah, that's 3 decimal places. So there you go, 2.089, using successive, whatever that's called, successive approximations. Again, this is something that a computer program can do instantaneously. So it's really good for you to know the logic, the rationale behind it. I'm not really interested in making sure that you can plug things into your calculator the right way. So there you go. There you have it. Check on learning, and I will see you in class. Bye now.